Hello, this is Professor Beda Ahmed. Today we will be doing chapter 4, Carbon and the Molecular Diversity of Life. What makes carbon the basis for all biological molecules? So carbon can form 4 bonds and therefore can bond up to 4 other atoms or groups of atoms. Carbon can bond to other carbons resulting in carbon skeleton, and carbon can also commonly bonds to oxygen, hydrogen, and nitrogen. The properties of a carbon-containing molecule depend on the arrangement of its carbon skeleton and on its chemical groups. Signaling molecules that is shown here, dopamine, has many functions, including promoting mother-infant bonding, and it depends on the chemical groups. Those are responsible for the carbon molecules function. Compounds containing carbon are said to be organic, and their study is called organic chemistry. Organic compounds range from simple molecules such as methane, CH4, to colossal ones such as a protein with thousands of atoms. And remember that, keep in mind that most organic compounds contain hydrogen atoms in addition to the carbon atoms. Carbon has 6 electrons, with 2 in the first electron shell and 4 in the second shell. Thus, it has 4 valence electrons in the shell that can hold up to 8 electrons. So a carbon atom usually completes its valence shell by sharing its 4 electrons with other atoms so that 8 electrons are present. Each pair of shared electrons constitute, as you know, covalent bond. In organic molecules, carbon usually form a single or double covalent bonds. Each carbon atom acts as an intersection point from which a molecule can branch off in as many as 4 directions. This enables carbon to form large complex molecules. There are 4 ways that carbon skeletons can vary. They can vary in length to carbon skeleton 3 or more than that. The carbon skeleton may contain double bonds in different position. Carbon skeleton can branch, and carbon skeleton can form or can present offering. Hydrocarbons are organic molecules consisting of only carbon and hydrogen. Hydrocarbons are the major component of petroleum, which is called a fossil fuel because it consists of the partially decomposed remains of organisms that lived millions of years ago. So mammalian adipose tissue, the mammalian adipose tissue cells stockpile fat molecules as a fuel reserve. This colorized micrograph shows a part of a human adipose cell with many fat droplets, each containing a large number of fat molecules. This is a fat molecule. A fat molecule consists of a small hydrocarbon component joined to 3, which is small hydrocarbon component, joined to 3 hydrocarbon tails that account for the hydrophobic behavior of fats. The tail can be broken down to provide energy. So the three cells responsible for the hydrophobic of fat when we drop one drop of fat in a water. It will aggregate. The black triangles represent carbon atoms and the gray balls represent hydrogen atoms. Isomers. Iso comes from Greek word. It has the meaning of equal. A variation in the architecture of organic molecules can be seen in isomers. Those are compounds that have the same numbers of atoms of the same element, but different structures and hence different properties. We will examine three types of isomers. Structural isomers. Structural isomers different in the covalent arrangement of their atoms. For example, the 2,5 carbon compound both have the same, or they both have molecular formula C5H12. They have the same number of carbon and hydrogen, but they differ in the covalent arrangement of their carbon skeleton. The skeleton is straight in one compound, but branched in the other. Put in mind that the number of possible isomers increases as carbon skeleton increase in size. There are only 3 forms of C5H2, 2 of which are shown here, but there are 18 variants of C8H18.